Hello, friends. Welcome. You're here for pre-calculus trigonometry, and we're going to start talking about section 6.1. So, section 6.1, we talk about trigonometric functions of acute angles. We have several symbols here. So we need to know these symbols. They're just Greek letters, which we use to sometimes represent variables, specifically angles. The first one would be pronounced alpha. When I write it, it looks like that. We have beta. My beta looks like this. Gamma. It might look a little better like this. One we use a whole lot, this next one, theta. And the last one you see here is phi. So just an idea of what those guys look like. That is not a phi. That's a better phi. So that's what they would look like when I'm using my best handwriting. You just need to know what the variables are, and when you see them, understand that they probably represent an angle. So these are all symbols that we use to denote or represent angles in trig. An acute angle is an angle who measures between 0 degrees, and actually it's not equal to, so 0 degrees and 90 degrees. You've probably also heard before about right triangles. Right triangles are triangles with two acute angles and one right angle. Looking at this picture here, I have a right angle measuring 90 degrees in my lower left corner. I have two acute angles. This one up here at the top I might call alpha, and down here at the bottom I might call that beta. The two things that we want to know or make sure that we pay attention to is these two sides which create that right angle. Those are both called the legs. And then opposite the right angle, it's always opposite the right angle. This longest side is called the hypotenuse. Okay, so the hypotenuse is the longest and it's opposite the right angle. So it's opposite the 90-degree angle. And so you see, here's my right angle. The side opposite is that. The two legs are both opposite the acute angles. So now that we understand the shape of a right triangle and what an acute angle is, we might want to talk about the Pythagorean theorem. Now, the Pythagorean theorem, this only works for right triangles, which means you have to have a 90-degree angle. But the way we can think about that Pythagorean theorem is a squared plus b squared equals c squared, or rather, leg squared plus leg squared equals that hypotenuse squared. All right, so either of those makes sense, but we just generally say a squared plus b squared is c squared. A and B represent the shorter legs. C represents the longer hypotenuse. The order for which one is A and which one is B doesn't matter because it's addition, and so addition's commutative. Commutative means 2 plus 3 versus 3 plus 2, switching the order. They still mean the same thing. So as we start talking more about these right triangles, we're going to talk a little bit about right triangle trigonometric function values. And so what we want to think about is we're always going to have some right triangle, at least in this section. We've got a right triangle, and we're going to be referring to a small acute angle. So I'm going to use, actually I wrote alpha, but I'm going to call that acute angle theta. So what you want to notice is that in relation to theta, we have a side that is opposite, and we have a side which is adjacent. And furthermore, then we also have that hypotenuse. So opposite's always going to be across. Adjacent is going to be touching that acute angle, which is being considered. So if we have a right triangle and theta represents the acute angle, as you see here, the way we're going to define these trig functions, we'll talk about sine. Sine is spelled S-I-N-E. We abbreviate it with just S-I-N. So I can say that sine theta is equal to opposite over hypotenuse. Cosine, which is sine's co-function, sine, and then you add the co, it becomes a co-function. So cosine, written C-O-S-I-N-E, abbreviated cos, or cos, but it's cosine. So cosine theta is going to equal adjacent over the hypotenuse. And then we also have tangent. So tan theta is going to always equal opposite over adjacent. Now, these three definitions I have written down here, you need to write on your paper, and you want to commit them to memory for good. All right, so we can abbreviate this. I can say, well, sine theta, I'll just say O over H. Cosine theta is A over H. And tangent theta is O over A. And so a way that we write this, a mnemonic device we might use, we say SOHCAHTOA, SOHCAHTOA, however you want to remember it. I like to write it like this. You can write it all in a line. You could say some old hippie caught another hippie tripping on acid. Whatever works, all right? That's what a mnemonic device is. So, but we go through here and we say SOHCAHTOA or SOHCAHTOA. You may have heard that before. So that's just a mnemonic device to help us remember these important trigonometric function value ratios. So you'll see here, I also have written sine, which we read as sine, cos is cosine, tan is tangent. We also have reciprocal functions. So these are reciprocal. So cosecant is reciprocal to sine, secant is reciprocal to cosine, and cotangent is reciprocal to tangent. Now, what does reciprocal mean? Reciprocal means we flip that fraction. So if I think about the fact that, let's erase some of this so I've got a little more space. I'm going to erase these definitions I wrote. You've already written them on your paper. So thinking about our reciprocal functions, we just said that cosecant is reciprocal to sine. So cosecant, abbreviated CSC, so CSC theta, if we find the reciprocal of that ratio, O over H, that's going to be H over O, hypotenuse over opposite. The same with secant, secant being reciprocal to cosine. Secant, SEC theta, that's going to equal H over A. And then lastly, cotangent relating to tangent. COT theta, since tangent's opposite over adjacent, cotangent's going to be adjacent over opposite. So we've got three trig functions, and then we know which functions are reciprocal to them, and then it's easy for us to redefine or determine what these other three trig ratios are. So now we have 6 trig ratios. And again, these are all things you want to commit to memory. So let's do an example before we end this video so we know what these reciprocal identities mean. So remember, and this is what you're always going to write when you're thinking about this, SOHCAHTOA. All right, so here we have a acute right triangle. The right isn't specified, but I drew that right in there. We have 2 angles. We have a alpha up here between 12 and 13, and a theta down here between 5 and 13. So since this is 90, the sum of these other 2 angles must be 90, which means that they both have to be less than 90 degrees. All right, so one thing we know is we have a hypotenuse. The hypotenuse is opposite that right angle. And the hypotenuse is always the longest side, so the hypotenuse is 13. Now, if you notice, we've got 4 examples here, A, B, C, and D. A and B have thetas, C and D have alphas. So we're going to have to change our method of thinking compared to, considering this theta versus alpha. So let's see, sine of theta. Sine of theta, that means I need to go to angle theta and determine which side is opposite and which side is the hypotenuse. Now the hypotenuse is never going to change, but opposite and adjacent can switch themselves around. So the side which is opposite theta, 12 is opposite theta. 13 is my hypotenuse. Therefore, if sine is opposite over hypotenuse, I'm going to write 12 over 13. Tangent is opposite over adjacent. So which side is adjacent to theta? 5 is adjacent to theta. Therefore, if I want to write opposite over adjacent, that's going to be 12 over 5. So I've got 2 answers there. All right, so now let's think about cosine alpha. Cosine, as written in SOHCAHTOA, is A over H, or adjacent over hypotenuse. The adjacent side to alpha is 12. Adjacent is touching alpha. So 12 is adjacent, and the hypotenuse would still be 13. So cosine alpha is also equal to 12/13. All right. The last one we have here is secant alpha. Secant, which one is that reciprocal to? Sine has cosecant reciprocal to it, and cosine has secant reciprocal to it. So, I don't want to confuse you too much, but I think about those cos attached to the front. We have sine and cosine, secant and cosecant. Right? So you've got 2 pairs of co-functions, but the reciprocals, they each get one co and one not co. So we have sine reciprocal to cosecant, and secant is reciprocal to cosine. However it works, you just need to remember it. Anyway, secant's reciprocal to cosine, so that means that secant theta is going to be hypotenuse over adjacent. I'm sorry, I wrote theta, but we're talking about alpha here. Secant alpha is going to be hypotenuse over adjacent. So which one is my hypotenuse? 13. It's never going to change. 13 is always opposite the right angle. Which one is adjacent to alpha? And that would be the 12. So my hypotenuse is 13, my adjacent side is 12. And we could have skipped that because we have cosine right here. And secant is reciprocal to cosine. And you'll see here 12 over 13, 13 over 12. You see that reciprocal relationship. So again, what I was talking about when I remember that, I've got sine, and it is reciprocal to cosecant, whereas cosine is reciprocal to secant. So my secants are together, this one has a co, my sines are together, the bottom one has a co. However it works. Let's look at just a little bit more in this video. So we've got some reciprocal function definitions. So we defined them a certain way, but we're also going to rewrite them here. So even though I know that sine is opposite over hypotenuse, and therefore cosecant is hypotenuse over opposite, we can also write it this way. I can say that cosecant of any angle theta would be 1 over sine of theta. Secant of any angle theta would be 1 over cosine theta. And cotangent of any angle theta would be 1 over tangent theta. So this is just another way of remembering what we've already stated. Cosecant, secant, and cotangent, those are my three reciprocal functions, and they each have a specific trig function that they are reciprocal to. And lastly, each one of these, I could reverse them. So I could also say, well, sine theta is 1 over cosecant theta. Cosine theta is 1 over secant theta. And tangent theta is 1 over cotangent theta. So there we have it. We've talked about acute right triangles, and we've identified our three trig ratios that we want to store in our brains. We use SOHCAHTOA, and then we've talked about their relationship to the reciprocal functions. So email me if you have any questions. I'm here to help.